Okay, so rationalizing denominators is a skill that can't highlight is a skill that is necessary for some problems in this section and coming sections. Sometimes we have to divide by square root, but we're not allowed to have square roots in the denominator in our final answer. It's not considered to be simplified. So the way that we fix our denominator, we turn it into a rational number. That's why we call it rationalizing. Is we can actually multiply both the top and the bottom by the same number. And we want to multiply by the square root of 5, or whatever the square root is, because you want to match it. So when you do this in the denominator, square root of 5 times square root of 5, since they're both square roots, you can multiply them together into a single square root. It'd be the square root of 25. In the numerator, square root of 3 times square root of 5 is the square root of 15. Now, don't be tempted to simplify 15 and 25 right now. The goal is to get the denominator to a point where it becomes rational. And the reason it's rational is because we know that the square root of 25 is just 5. There's no square root there anymore. Now, in the numerator, I still have the square root of 15. Square root of 15 does not simplify. There is no perfect square that's a factor of it. And you might be tempted to say, oh, 15 over 5 simplifies because it's a 15 of 5. But in reality, it doesn't. The 15 isn't a square root. It's irrational. 5 is not a square root. It's rational. Those numbers are not eligible to simplify. The only thing you could simplify the 5 with is the number in front of the square root. If there's no number there, it's really a 1. So really, I have a 1 over 5, and a 1 over 5 does not simplify anyway. So this right here is the problem. If we look at this next problem, 4 square root of 3 over square root of 2, we're going to rationalize. We have to multiply by square roots of 2. And the denominator, because that's what I'm trying to fix, I have square root of 2 times square root of 2, which is the square root of 4. In the numerator, I have a 4 that's not in a square root. It's going to still be not in a square root. But square root of 3 times square root of 2, they're both square roots, they become square root of 6. Now my denominator, I rationalized it, so I know the square root of 4 is 2. And so the 6 and the 2 cannot simplify because the 6 is irrational, 2 is rational. But this 4 in front and the 2 aren't. Those are both rational numbers. They're eligible to simplify. I can divide them both by 2, giving me a 2 over 1. So since my final denominator is a 1, I don't need to write it as a fraction. I don't need to write the denominator. So 2 square root of 6 is the answer to this problem. And lastly, 8 squared of 10. So once again, I'm going to multiply by square roots of 10. In the numerator, I have 8 times square root of 10. One's rational, one's irrational. They don't combine. I just put them like that. And the denominator, square root of 10 times square root of 10 is the square root of 100. Hopefully we realize the square root of 100 is 10. 8 over 10 simplifies because I can divide them both by 2, 4, and 5. Sometimes what you have left in your square will simplify. In this case, it doesn't. There's no factor of 10 that's a perfect square. So I have 4 square roots of 10 over 5. And this is a perfectly acceptable answer because there's no square root in the denominator. It's a rationalized denominator. So you'll have to use this skill sometimes throughout this next section. So I wanted you to practice this a little bit.